Alright guys, in this video, the last two examples that we have for this section is dealing with adding and subtracting radicals and then multiplying radicals. The first example here I'm going to show you is how to add and subtract radicals. Now the big thing that you guys need to know of is what a like radical is. Now that's the same thing as like a like term. So for example, let's say if I had something like this where it was like 5x plus y minus 8x. So what you guys would do here is you guys would go ahead and, oh, okay, I know that's a like term of that, and you'd put those two together and you'd say 5x minus 8x would be negative 3x plus y. Alright, so I'm going to try to relate that to this over here. In this example I have no idea what x is, I have no idea what y is. Just like over here, I don't really know what the square root of 7 is, and I don't really know what the square root of 11 is. We could figure it out, we could get a calculator, we could approximate it, but off the top of my head, I really don't know. I have an idea of what it would be, but I'm not really concerned with that because I don't even have to deal with that. All I have to concern myself with is figuring out what the like terms are. So what you should do is circle the like terms. So this has a root 7 in it. This one doesn't, so it's not a like term. This has a root 7 in it, so that is a like term. Now if you want to, I don't do it normally, but just to show you, you can put together the like terms and then put the other term together over here. You notice I didn't do that over here, so you don't really necessarily have to do it here if you don't want to. But all you have to do is focus your eyes on that coefficient, right? So it's really 5 times root 7 minus 8 root 7, or 8 times root 7. I don't know what root 7 is, so all you have to do is put 5 minus 8 together, and it's going to be negative 3 root 7, and then can't do anything with the 11, so that would be your final answer. So look for like radicals. I can't say that enough. Like radicals, same thing as like terms, like radicals, and then you just combine your like radicals, and you're done. I don't have to do anything else. So here's another example, adding radicals. Remember the first step in what we should always look for to see if there's like radicals. Right off the bat, I can't see any like radicals. So you might say, well, sweet, I'm done. I don't have to do anything. However, there is something you need to do. You need to look to see if you can simplify. I cannot simplify this down at all. There's no perfect square factors of 5, but I do know that I could split this up to be 5 times 4, right? Because 4 is on my list. Remember these lists that we had before? Try to memorize those if you can. It's easier to factor 20 into 5 and 4 when you know that we're looking for a perfect square to be a factor of 20. So 4 is a perfect square of 20. So that's why I factored it as 5 and 4. So you could do it that way if you wanted to. You could make a factor tree. I always just try to think in my head what perfect square is a factor of that radicand. So let's look at this, and another thing I forgot to mention previously is the index. The indices have to be the same. So the index is a 2 and a 2, so that means that I can put these together. So make sure that the index is the same, and then when I do this out, square root of 4 is 2, so that comes out front. You can skip this step and just say it's 4 if you want to. Right off the bat, right off the top, you can do that, but I'm trying to show you step by step because it is a video, and I'm showing you where I'm getting my numbers from. Alright, so now look at this. Do I have like terms? Not like terms, but like radicals. Yes, I do. I have a like radical of root 5 and root 5, so that means all I have to do is combine the 10 in the 4, which would be 14. So your final answer would be 14 times root 5, and you're all set. Alright, here's another example, and remember in the previous example I said look at the index, look at the indices. So plural for index is indices. 3 and 3, they are the same. Then I want to look to see if the radicand is the same. Is the radicand the same? Yes, so that means that I have like radicals. So all I have to do is work. This one's actually pretty straightforward. Just have to focus on the 6 and the 2. What's 6 plus 2? Well, that would be 8, and then you'd have the cube root of x. So 8 times the cube root of x. And that's it. So that's how you add and subtract radicals. Remember, like radicals, you have to have the same radicand and you have to have the same index. All right, here's the last example that we're going to look at, and we're going to look at multiplying radicals. Now, I believe the book shows you how to do this in 2 methods. You could basically distribute first and then simplify. I like to try to break this 75 down as much as I can before I go ahead and distribute. So what I'm going to do first on this one is I'm going to think of, well, what perfect squares are factors of 75? And that one I hope you guys are good with, because I feel like 25 was always an easy one. Not 25, but your tables of 5 were always a nice one. You'd always get those ones right? All right, so now from here I can go ahead and simplify this. This would be 5 root 3. And now from here you could distribute again if you wanted to. However, I just noticed that this guy I can go ahead and put together. So 1 minus 5 would be negative 4 root 3. And then from here, what we're going to do is we're going to basically just multiply. So when you multiply, all you have to do is first make sure the index is the same, which it is, and then you multiply the radicand. So this would really be negative 4 root 15. And that would be your final answer. And again, there's different ways of doing that. Maybe I'll actually show you here. So once you simplified it, let's take it over here, and hopefully I don't run out of space. But you could also do it this way too. If this is less confusing for you, you could do it this way. So you can go ahead and distribute. This would become 1 root 15 minus 5 root 15. And then you do that out. What's 1 minus 5? Well, it'll be negative 4 times root 15. Because these are like radicals, just as these were like radicals. But whatever way you want to do it, everyone should get the same outcome for that one, which is negative 4 times root 15. So pause this, rewind it. Remember, it's a video. Take good notes, summarize it. Make sure you bring some questions if you are confused on this. But remember, when you multiply, index has to be the same, and then it doesn't matter if the radicands don't have to be the same. So if you think about it, I can multiply this out because all I'm doing is multiplying the radicand. Index is the same, so I can do that. So all we're doing, okay? Same thing here, 5 times 75. You could do that, but what I did first was I simplified to make my life a little bit easier. But again, you can do it many different ways. But the big thing is make sure the index is the same, and then you can multiply the radicand. So a little bit different than when you add or subtract, because when you add or subtract, the radicand has to be the same for it to be a like radical. But again, remember, make sure that you learn the perfect cubes, perfect squares. But that's about it. I'll see you guys in class.